turn to the top of page 653, and we're going to start off with a proof. And we're going to prove one of our new identities. And we write it out. And usually, when I have more time, and I know that we're going to be in class for the next couple of weeks, I would say try it. And I'd let you get stuck for a minute, because it's already in sine and cos, and you've never dealt with a 2 inside of sine, so you try to make up math that doesn't work. And after a minute of getting stuck, I would say I'm going to give you a hint. And the hint that I'm going to give you for this goes back to mathematics you learned a long, long time ago. You have to use the mathematics of kindergarten to figure out this proof. So what are some things you learned in kindergarten? You probably didn't learn subtracting in kindergarten. Say some math you might have known in kindergarten. Like what kind of addition? 8,032 plus 79? 1 plus 2, 1 plus 1. There, you got it. Go. Now try to prove this. You just actually said the kindergarten math that you need to use. Right? You've got a 2, and you know that in kindergarten 1 plus 1 equals 2. So using that knowledge, that 1 plus 1 equals 2, what can I write 2 theta as? Theta plus theta. And then this takes us to 7.5, and that can be alpha and that can be beta. So if I do sine alpha cos beta plus cos alpha sine beta, right? And you know, do you remember in kindergarten when you were in your math class in kindergarten and you said to your teacher, when am I ever going to use this? You probably didn't say that in kindergarten. But students say that all the time in high school, in all their classes, right? When am I ever going to use this? Well, way back in kindergarten, now we're like, oh, I can use 1 plus 1 equals 2. And it's so helpful. And here again, these are like terms, right? They're exactly the same. 1 plus 1 equals 2 of them. I really do actually hope that you have used your addition skills more since kindergarten than just this moment in time. I'm sure you have. But we can use this to prove this. Now you will never be asked to prove this on a test or quiz or an exam because it's one of your new identities. It's on your formula sheet. We can go right there. These are our new formulas. We have one formula for sine 2 alpha. We have 3 separate formulas for cos 2 alpha that are all the same. This is just on the next page. Like for example, if you had cos 2 theta, one of the proofs is cos squared minus sine squared. Can you see that you could change the sine squared to 1 minus cos squared, rearrange things, and get 2 cos squared minus 1? And you could also take the cos squared and change it to 1 minus sine squared to get 1 minus 2 sine squared. So let us go to example 1. Now that we have our double identities, okay, just like chapter 6 and just like 7.5, we had a double triangle question in trigonometry when you're figuring out something and they give you information of what quadrant it's in. Draw a triangle. That strategy comes up over and over again. Theta is in standard position in quadrant 4. And cos of theta is 2/5. So what do I know? I know here it is. I know this is my reference angle. I can draw my triangle back to my nearest x-axis since cos is 2/5. I can label adjacent over hypotenuse as 2/5. A squared plus b squared equals c squared. Again, you should be getting pretty quick at this. Square root of 21. And so now we know sine of theta and cos of theta and tan of theta. And if we wanted, secant, cosecant, cotangent of theta as well. Determine the exact value of sine of 2 theta. Then, when figuring out sine of 2 theta, or cos of 2 theta, or tan of 2 theta, you have to use the identity, because there is no 2 theta listed in our triangle. The only thing that's in our triangle is theta. So we need to change sine 2 theta to 2 sine theta cos theta, and then we need to substitute. And just like before, you do not know what theta is. So just like that common mistake I pointed out yesterday, that in some classes 70% of students make that common mistake. Make sure you watch the videos, okay? With this one, same thing. We know that cos of theta is 2/5. We just, from our triangle, can say that sine of theta is negative root 21 over 5. And so when we substitute all of that for sine theta and all of that for cos theta. Multiply things out to get a single fraction. Negative 4 root 21 over 25. Remember, that's 2 over 1. Remember how to multiply fractions. Multiply the tops, multiply the bottoms. And we get our answer. Now in part B, part B asks you to find cos of 2 theta. And there's 3 formulas to choose. And all 3 will give you the right answer, but always there is one that's considered better than the other 2. In this case, the one that is considered better than the other 2 is this one. Why? The other formulas are up here on the wall: cos squared theta minus sine squared theta, and 1 minus 2 sine squared theta. And choosing this one is specific to this question only. It doesn't use sine. So why would that be better to use the one that doesn't use sine? Cos was given to us in the equation, right? Cos of theta is 2/5. To get sine of theta, which we did correctly, negative root 21 over 5, we had to solve for that. Is there a possibility you could make a mistake in solving? Yes. Could you have forgotten the negative? Yes. Right? There's just places where you could have made an error. So when you have a choice, if you can avoid that, that's better. In this situation, right, that sine of theta is the right value. And using it's not going to affect my answer. But this is better because I can use the value. Now I know that cos of theta was given to us to be 2/5. How do you write cos squared of theta? Well, then it will just be 2/5 times 2/5, or 2/5 squared, minus 1. I need to write my final answer. Right? Squaring that will give me 4 over 25. Minus, and I'm going to change the 1 to 25 over 25. So I have 8 over 25 minus 25 over 25 gives me negative 17 over 25. Sometimes when you learn new math, you make your old math harder because now you have more knowledge and you have choices to make when solving things. So I'm going to add 2 more little questions here of examples of this. So here's the first one. It's going to be evaluate. And we're going to evaluate 2 sine of pi over 12 cos of pi over 12. There are 2 ways that we could solve this question. If I gave you this question yesterday, I would make it a 7-mark question, because we learned about pi over 12 questions yesterday. So you're going to sort of be trained from yesterday that you see, oh, pi over 12, I know how to do those. 1 pi over 12 questions, usually 3 or 4 marks. This would be 2 pi over 12 questions put together. Most likely would be 7 marks, maybe 8 marks, because you have to simplify. Okay? But today, we're learning about the double angle identities. And again, all of those identities, you have to have them mostly memorized so you can recognize when you have options. If you don't have it memorized, your brain will see pi over 12 much quicker than it sees this formula, right? We just learned this formula. You haven't memorized it yet. Can you see that we have the right-hand side of that formula? So because we have the right-hand side of that formula, we can change it to the left-hand side of the formula. That's what identities allow you to do. And 2 times pi over 12 is pi over 6. And sine of pi over 6 is 1/2. And that's a lot less work than doing the alpha plus beta formulas for 2 pi over 12 questions. Here's the next example. This one was more difficult because the pi over 12 might trigger you to take the longer method. So this one is more difficult than this one, but I could also have, on a non-calculator part of the exam, I could get you to evaluate a pi over 8 question. You're like, what? Where's pi over 8 on my unit circle? Again, you need to have memorized, or mostly memorized, that cos of 2 theta is 1 minus 2 sine squared theta. And we have the right-hand side of that formula here. So 1 minus 2 sine squared theta, I could rewrite this then as cos of 2 theta, 2 times pi over 8, it's pi over 4, that's on my unit circle, I get root 2 over 2. And then this would be about the extent that you would get, but you could have questions that say, what's the value of just 2 sine squared theta? 2 sine squared pi over 8. And then you'd have to do some rearranging to make it work. But okay, yeah. Question number 9 for practice.